Good morning, everyone. Let me share my screen with you. I will be guiding you today through the vast concept of smart energy systems and how this topic is covered in our current program. Let us first take a step back and look at the policy framework that is applicable to this topic. First, on a global scale, we have the United Nations Sustainable Development Goals, and in particular, number 7, to ensure affordable and clean energy for all. Now, the EU is ambitious too, as it strives to be the first climate neutral continent by 2050. As you probably know, the European Green Deal provides an action plan to make the EU's economy sustainable. Now, to deliver on this priority, there is a Fit for 55 package and to reduce emissions by at least 55% by 2030. This will cover wide-ranging policy areas from renewables to energy efficiency and so on. Now, smart energy systems are crucial in this respect to obtain a deep decarbonization of all sectors in the economy and to deliver on the greenhouse gas emission reduction targets. And this is also explained in the EU strategy for energy system integration. Key elements are, as I said, the integration of energy carriers, infrastructures, and the consumption sectors in a connected and flexible system, as opposed to working in silos, and a system that is more sustainable, using renewables and more cost efficient for society. Now, the term smart energy systems is not really used as such in the current cooperation program, but the elements are, and they fit in particular with the specific objectives of the low carbon priority. Now, within this low carbon priority, we can easily identify 10 projects with a direct obvious link to the topic, representing 210 partner organizations and a combined budget of 73 million euro ERDF invested. Indirectly, our program hosts a multitude of projects over the different priorities that touch upon similar concepts of sustainability, energy efficiency, and so on and so forth. So if we look at the combined impact of all our projects on program level, then we expect an annual decrease of CO2 emissions by 133,000 tons at the end of the program, as also said in the plenary just before, and 38 megawatts of additional renewable energy production. When we look at our currently approved projects, and with this integration element in mind, we can broadly identify two categories of projects. We have projects that have the electricity grids and energy management system as a central part of their projects. And then, I'm thinking here of smart grids, also about storage, etc. And then we have also projects that particularly focus on district heating and cooling. Some examples maybe, we have, for example, the Clean Mobile Energy Project. That is a project that provides an IEMS system. And this is an open source energy management system to manage local clean energy generation and supply in an efficient way. Mr. Peter Zwart of the City of Arnhem, who is a lead partner of this project, he will be hosting a round table in the second part of this breakout session. Then we also have the D2 Grids project, for example. This is a project that is rolling out a so-called fifth generation district heating and cooling system. The project was just granted an extension through our call for capitalization. And with that, it wants to enhance the integration of such a system with the power grid, so using locally generated solar energy. Now, today I'm also excited, as Sarah said, to welcome two very interesting speakers from the Red Wolf and Heatmap NWE projects to tell you more about their work and impact on the NWE area. I would like to thank you for your attention, and back to you, Sarah.
And thank you, Eva, very interesting. So I just remind everybody, if you'd like to, you can add questions to the chat and we'll attempt to address them later on. Now we'll hear from Leeds Beckett University through Dr. Giuseppe Colantuono. Please take it away. Thank you.
Thank you, Sarah, and thank you for the beautiful introduction of Eva. We are now going to share the presentation of Red Wolf. What is? Let me see if I'm able to share screen here. Let me share screen. Okay. Okay, it should be sorted slideshow. Let me from me. Okay, here we are. Red Wolf stands for Rethink Electricity Distribution Without Load Following. So this acronym is explained here. As you can see from this picture, we are dealing with houses. So one of the the main point of this project is to reduce CO2 emission from houses in Northwest Europe. The picture you can see here is from a pilot house in France, in Montbéliard. We have other pilots in Republic of Ireland and in England. Now, at the bottom of this presentation, there will be a slide with some technical explanation. So at the moment, I will stay general, and so I would like to stress that Red Wolf aims at reducing CO2 emission from Northwest Europe houses. Why? Because first of all, housing is one of the highest sources of electricity of energy consumption. Actually, it's around 40%. Particularly Northwest Europe is characterized by a cold climate. I mean, everybody probably knows that heat is still on in May in several areas, for sure in the UK, and there are also other particularities of this area. So, for example, PV energy, that is one of the future or the most credited future sources of power, is very seasonally dependent. In December, January, generation is almost zero, and so the need to address the energy system in Northwest Europe stems from these facts here. Now, regarding houses, we are aiming at reducing 240 tons from about 90 pilot houses. So how is going to happen? Now, the project deals with peak demand. So the project aims at reducing peak demand. Everybody knows that when you wake up in the morning or when you come back in the evening, there is an intensification of power demand. So there are specialized plants that need to get online that are less efficient, so they will generate more carbon. Now, what we are going to do is to store electricity at times of low demand in a way that we will avoid then this peak. That is also the main reason for dirty energy to be on the grid. So, in order to do this, we are mainly following the CO2 index on the electric grid. The CO2 index will tell us when the electricity will be cleaner and when it's worth to store this electricity. Now, another key feature of this project is that we are splitting the energy that we are storing. So we are splitting the electricity that we are storing between thermal reservoirs and batteries. Why? So there are two key explanations here. The first explanation is that batteries are still very expensive, and the thermal storage is a much cheaper option. So if you heat hot water or you heat bricks in storage heaters, that is what we are doing for space heating, you can store energy for a few hours and use it when you need it more. Now, obviously there is a downside. Probably some of you have heard the term low value heat or low grade heat. So the point is that when you generate heat, then you cannot get electricity back in any significant, any relevant amount. So the point is that as soon as you convert energy in thermal, as soon as you convert electrical energy in thermal energy, there is no comeback. So we address this by making some predictions. We have an algorithm. We developed an algorithm that is running on a server that has been installed in one of our partner premises, the Institute of Technology Sligo in the Republic of Ireland. This server is connected with the houses. We'll get data from the houses and we'll send instructions back to the houses. The reservoir, the storage reservoir in these houses will take electricity when it's greener and when it's not needed also, because one of the main troubles with renewable energy is that it's non-dispatchable, so you cannot switch it on and off. You have to harvest it when it's available. So in order to harvest it when it's available, you need to have a place to store it. Now, the storage can be on the grid side, and is the solution that has been followed more often so far. What we are proposing is to place storage on the house side, on the consumer side, and to create a system that is self-regulating. So there are also examples of storage reservoirs or even appliances that are driven by the electric grid. We are not doing anything like that. We want to bring on the market, to bring on the energy system houses that self-regulate. They can follow grid indices like CO2 index. We could also follow price or other indices, and then these houses self-regulate and take energy in order to stabilize the system. Take energy at the optimal time, basically. So there are other objectives apart from reducing tone. There are some sub-objectives like these come from the indicators of the program. So collaboration with enterprises and engaging the general public, so students in our case. We are holding a summer school in this summer, next summer in July. We had is an online event to last a few days. We will have we had an unbelievable amount of replies. We received almost 200 applications. So from the United States to East Asia, from everywhere. So this testifies really the demand that there is today for a training and an education in the field of in the combined field of energy and environment. So the results so far: 43 pilot houses have been installed. By the end of the project, we aim at installing another 50, more or less. And then we had a big integration between engineers and installers with universities, and also with the energy system that is peculiar to every country. So when you travel, you can see that if you go from England to France, you have to buy an adapter for your laptop. So this is just a simple example. But if you open the meter case or the meter room where everybody has their electricity meter and their main connection, their main supply, there are huge differences between a country and the other in Europe. So this is something we are achieving. I think we are exposing different countries' technicians to what's going on in the nearby states. On the minus side, I have to mention that all these things needs to be done following a formal tendering procedure, and this is quite difficult because the time of tendering is very long. So sometimes it takes 1 year or more. If some mistake is made, you have to tender again. So this is something that really has delayed a bit our pilot installation process. We are grateful to Interreg Northwest for having awarded of the capitalization call. This is an important result for us. We thank the program for their continued support and the trust in our work. We are using these resources in order to extend this energy system to a different setting, so to training and school and academic settings. So basically we are moving from houses to shared spaces or even commercial spaces in the future in which many people gather. In the future it can be offices, it can be any environment basically where people live. Regarding the partnership, I think that so the priorities of the program were very well formulated. At least, let's say, this project found almost a perfect correspondence between the ideas that drove it and the priorities that are set by the program. So really, this program has set up a terrain, a prolific, let's say, a positive terrain for this project to thrive. The long term. From the long-term point of view, I already discussed the capitalization call, and we are also looking for future collaborations to extend our system to different technologies. We have been contacted by companies that would like to extend our basically to adopt our control strategy to their existing storage reservoirs.
Excuse me, Giuseppe, please, we need to wrap up, I'm sorry.
Yeah. Have I got another 30 seconds or not?
Yes, go for 30 seconds. Thank you.
Thank you very much, Sarah. So this is a small slide, the last technical slide. Basically, you can see that there are the storage reservoirs here, a battery, a space heater, and a water heater. They are driven by a switch, and the switch is controlled by a programmable logic controllers that then exchange data with the server that I mentioned in the beginning that is installed in Sligo, Ireland. So that's it. Thank you very much for your time, and it was a pleasure to speak here.
Thank you, Giuseppe, for your presentation, sharing so much in this time-limited situation. There are some questions for you, which we will try to address after the next presentation. So I'm pleased to pass the floor to Declan McCormack from the City of Dublin Energy Management Agency, CODEMA. Declan is the project lead for the Heatnet project, and he has some impressive results to share. Over to you, Declan. Thank you.
Thank you, Sarah. Thanks for that. Thanks, Giuseppe. I can confirm what Giuseppe said. I have the heating on at the moment in a very wet and windy Ireland. So I'm just going to talk to you very briefly this morning about the Heatnet Northwest Europe project. I'm Declan McCormack, as Sarah said. I'm the project manager in CODEMA. We're Dublin's energy agency here in Ireland, and we're the lead partner for the Heatnet project. We started the project in September 2016. I'll just start my slideshow for you there. Which seems an awful long time ago now, and we're due to finish up this year, August 21. So I suppose the first question was, why did we write the project? What were we trying to achieve? And what was the problem or the challenge that we were trying to contribute towards with fourth generation district heating? So in the EU, heating and cooling accounts for about half of the EU energy consumption. 72% of this is generated from fossil fuels, so huge associated greenhouse gas emissions with that. Also in central, north and eastern regions within the EU, for historical, political and other reasons, heating and cooling district networks accounts for about 50% on average of the market share. Whereas in northwest European regions, that's an average of about 5 to 7%. In some regions, in fact, below 1%, it varies. So these were some of the problems or challenges that we were looking at, but there was also opportunities that we saw as well within that, such as maybe with new EC climate plan targets for heating with 38 to 40% renewable content for that heating targets for 2030 at the moment. There's There's also a massive amount of heat loss or waste heat generation within the EU. In fact, if you utilised it all, you could satisfy the needs of the entire building stock. Obviously, all of it can't be utilised, but it just goes to show you as an example of the amount of waste heat and heat loss that there is out there. Another opportunity that has arisen lately is that a lot of these corporations and companies that are generating large amounts of this waste heat, so power generation, data centers, big industrial processes, etc., they're now seeing this waste heat as an asset rather than a liability, that either they can monetize it and sell it into district heating systems, or it can go towards their CSO, their corporate social responsibility, and their green credentials, that by providing this heat in some format that can then be counted as low carbon, this will reflect well on them in terms of their green credentials. So with the challenges and opportunities outlined, we wrote a broad objective for the Heatmap programme of developing transferable guidance on how to build these district heating and cooling networks, and fourth generation, ideally, district heating and cooling networks within Northwest Europe. I have to point out at this stage that the focus for the project was not technical, that we did reviews and saw there was a lot of technical programs already out there in terms of district heating and cooling, looking at those solutions. This one is more looking at what I'd call the softer measures on the ground within the region. So that's financial situations, regulatory guidelines, organisational barriers, governance, spatial planning, things like that on the ground that can affect the rollout of district heating networks. I'd also like to point out, I myself, I'm not from a technical background as well, for questions later. So if there's questions about delta T's and COPs and heat pumps and stuff like that, you can definitely put them in writing, but you mightn't get a full answer from myself. So once we had that objective for the HeatNet project, we went around structuring it of what would be the best way to deliver that. So we decided that would be writing work packages and deliverables around examining those local softer conditions in terms of governance, regulation, finance, etc., and the lack of them in a lot of regions where this is new. And then we could start comparing the different conditions and seeing what that meant in terms of rollout of district heating. We also funded 6 district heating investment pilots in the partner regions. These ranged from highly advanced ones, nearly 5th generation, and nearly towards what Giuseppe's talking about, that households actually providing the thermal storage and feeding back in, etc., to taking waste heat in data centres, to more traditional, maybe CHP and gas and waste to energy. From these investments, the idea then was that these would be rolled out obviously in real world conditions, and then those barriers and opportunities in the softer measures, regulations, etc., could be tested to see how it actually affects the rollout. They would be continuously evaluated and fed back into the project in a feedback loop to inform our outputs and some of our findings. We also wrote in peer-to-peer exchange that was between either webinars and those kind of methods, but also we had mentor-learner setups within the project itself. So we had really experienced investment pilot partners who are already running district heating networks, and then we had partners who are either little experience or no experience at all. So we set up that mentor program within the project as well. We funded 6 transition roadmaps in the partner regional countries. This was looking at the rollout of district heating in the short to medium term in different scenarios and what that would mean. And then all of these findings were going to be assembled onto an online guide to district heating for decision makers. And when I say decision makers, I mean people like municipality managers, senior architects, engineers, planners, people like that who are actually making these decisions on whether to go ahead with district heating outside the fully commercial district heating systems. The budget for the project was 11.5 million, and with 13 partners from 5 countries. Our targets, We want to make a 4,000 ton CO2 equivalent saving on the base of the district heating network within those countries. Add 3,000 additional units, commercial and residential. The HeatNet guide that I've talked about, and trigger at least an extra 1 million in leverage funding that was non-commercial. So I'm due to report on this in August, but first indications are that we've surpassed all our targets, which is great. And we will have the final targets when my report goes in August. They'll be available. The guide to district heating is actually live and online as we speak. It's at the address at the bottom of the slide there, so I'd encourage you to log on and have a look at that. What next? Well, I'm also glad to say that all the investment partners at the moment are either planning or carrying out extensions, either to their broader network or directly to the HeatNet pilots within that network. I think a lot of this was based on the project. Definitely the transition roadmaps were used for rolling that out, and the learnings, that expertise that we got from the mentors and the transboundary learnings that we got from that to these extensions and further pilots. The platform, as I said, is up live and is going to be continuously updated to go. And we'll maintain those stakeholder networks, our consortium, and all the people that we've met along the way for future opportunities and hopefully within the Interreg program itself. So was Interreg needed? And the answer is yes, most definitely. Everybody be glad to hear on the call. For a number of reasons, the part funding and the investments, these are up against fossil fuels, and it's very hard to compete with these as they've already established networks involved. Needed. The peer-to-peer exchange that I talked about was vital. Site visits for those decision makers, that was vital as well, actually bringing them to see these sites to make decisions, see this is possible and what structures in place. Paid for the work on the transition roadmaps and everything that went around them, and allowed that transboundary comparison between the regions. So the final takeaway from this is what are we proud of? What came out of the project? Well, obviously the guides that's up online there. Again, there's no substitute for seeing actual projects on the ground, pipes in the ground, heating being commissioned, buildings actually receiving heat from that. It's always great to see a project come to life in that. But I have to say, it's the consortium that makes it, the partnership, the extended partnership, affiliates. They really pushed this across the line, getting the expertise, the enthusiasm from the consortium from that really pushed such a big project along and made it successful. So that's my major takeaway from that is the consortium is make or break in all of this. So that's a very brief run through the HeatNet project. I know I didn't go into depth in that, but as I said, the guide's online, and I think we're going to have some questions and answers here, and my contact details are there.
Very good. Thank you. Thank you, Declan. We're a little bit behind time, so I think what we might do is ask Anka, if you don't mind, to please present just very briefly how the theme will be tackled in 2021-2027, and then we'll use the last remaining few moments to go through the questions that have come through the chat. So thank you, Anka. I'll pass over to you.
Thank you, Sarah, and hello to everyone here. Thanks for joining our event. What I want to do today is to shed a bit the light on the future program in relation to smart energy systems. So what we have decided already and what is in the loop. I have to share my screen 1 second. Okay, there it is. Sorry for that. So my name is Anke. I'm working for the Secretariat as a project officer, and I will shed some light on how the energy systems or smart energy systems will be tackled in the future. And as you have already heard in the plenary, that we'll have an entire priority just on smart and just energy transition. So I think that's good news. It remains an important pillar in the next program, as it has been already in the current program. And it will make me look at two aspects that were mentioned already this morning. So the one is to promote the energy or promote energy efficiency measures. And the second one is to focus on renewable energy promotion. This is the basics about the priority and the main objectives. So, but what does this mean in detail for this priority? What do we want to finance? What do we want to see? And what challenges do we address? And what we did, we looked at the challenges for Northwest Europe, of course. We did an analysis. We looked also on what we have financed and what we have to do in the future to really achieve this energy transition in the longer run. And what we came up with were specific challenges now looking at smart energy systems that exist in our area and that are mainly these four that I'm listed here. So one is really the low energy performance still in buildings and transport sectors. There's a really hampered effectiveness, you could say, for energy storage systems. There's still a very low deployment of decentralized energy production and or smart energy systems in our area. And there's a significant unexploited potential for improving the renewable energy production and consumption mix. So to say it maybe a bit more positively, what we found out, there are real opportunities in our area still. There's a huge potential to contribute to the energy transition, but we didn't make use of this potential yet. So we have solutions existing, like Declan was saying, technical solutions exist, but the gap or the challenge is really how to roll these out, how to apply them, how to make them happen everywhere or in the region suitable. So what we came up with, or the key question we came up with, how to exploit this potential in Northwest Europe, how to deploy these solutions more widely. And I think that is one of the key questions for the next program, to make solutions more widely applicable and to replicate them as much as possible. And how do we want to do this? Well, we came up with with three main types of activities. I mean, this is very general now how I put it, but it will become clearer when I explain it. Basically, in this priority, what we want is that projects look at joint strategies and action plans to be implemented. So, for example, creating or elaborating a strategy to expand value chains for renewable energies, or shift really to renewable energies in general, to make use of them, to implement action plans on local level to implement activities on energy efficiency or renewable energies. The second type of activity looks really at pilot actions to be upscaled and replicated, what I just mentioned, to really take existing solutions and roll them out to other regions, apply them somewhere else. These could be pilot actions, testing solutions on, I know digitize distribution grids, or optimize energy consumption or demand, facilitate the uptake of renewables in different sectors, in various sectors. That's really crucial. And then the third type of activity is the capacity building and awareness raising, which is a key element we want projects to focus on to really conduct training schemes for citizens, for businesses, for any kind of workers in key economic sectors that are crucial, being it heating and cooling or transport and mobility, but anywhere where you can implement renewable energy or energy efficiency measures. And of course, a lot of public awareness and campaigns to really take everyone on board for this just energy transition. Expected impact by project. The question was asked in the plenary about impact in the new program. So we said we didn't define yet anything on indicators, but what we looked at is what we want from projects in this priority is really to have this increased capacity of Northwest Europe communities in energy efficiency and other renewable energy solutions. And this could translate in increased awareness from citizens to businesses, to really have all stakeholders involved and knowing about what needs to be done, to have energy transition really embedded into territorial strategies and local initiatives, be it local action plans or whatever initiatives that are going on the ground. Increased capacity of stakeholders to translate energy efficiency principles into policies, services, products, and actions, and also more on innovative technologies, solutions, products, and services implemented in your projects. That is basically it on the priority for now, what I can tell for now, for the time being. As you know, the program is still being drafted, so nothing is final yet. The approval is envisaged early next year or late or at the end of this year. Let's hope everything goes smooth. And if everything goes smooth, then yes, you can expect the first call next spring 2022. And if you have any great ideas on this topic, then yes, stay tuned on our website, our social media, to get more information about the first call and what is expected from us. That was it. Thank you.
Thank you, Anke. So we're very close now to the 11:15 and 10:15 in the UK and Ireland start time for the round tables. I'm going to just put up on the screen the instructions, but essentially there will be a pop-up that you simply click the link for your preferred round table event. In the meantime, I can offer one question from the chat, please, for you, Giuseppe. A person in the chat asked about photovoltaic costs compared to traditional energy. And actually, before you answer, I also want to comment that Declan has agreed to share his slides with the participants by email after the event. Thank you. So Giuseppe, photovoltaic costs compared to traditional energy.
Well, this is a very complicated answer. So it depends, first of all, where you are. So what is the generation that is allowed by the weather where you exist? And second, there are some savings due to the fact that you can use photovoltaic locally without using the transmission lines. So this is a big saving for the electricity distributors. Obviously, in order to do this, you need to maximize self-consumption and to avoid to export as much as possible. Anyway, just as a general answer, in some places, like for example Italy, or other countries, other sunny countries, photovoltaics have reached parity with the electricity price already a few years ago. So yeah, so this is my answer.
Thank you, Giuseppe. Very speedy response. Declan, I'm not sure if you have much time, but there was also a question for you about how local residents were involved in the setting up of the heat maps. Thank you.
Yeah, no problem. And again, apologies. I thought I had my slideshow. I must have looked like I had learned it off by heart. So in terms of, we were dealing a lot with municipalities were most of the partners. So in terms of the local residents, a lot of that would have been social housing, affordable housing or the equivalent in those countries, particularly in Boulogne-sur-Mer. They're very involved with the local residents, and a large part of some of their deliverables was going in and meeting these residents, bringing them on board, getting their thoughts on the existing system and how that could be improved, and how energy poverty could be improved. In terms of the actual utility companies themselves, there isn't shareholdings that I know of. I can check with the partners for residents at the moment. Most of them are either not-for-profit run or municipality run. I'm not sure if that was the angle the person was looking for in terms of that.
Thank you, Declan. So while we wait for the pop-up of the round tables, we could move to another question. I think this one is back to Giuseppe, please. The seasonal limit of solar power at high latitudes that you did mention, where Northwest Europe is located, from November to January, solar generation is really limited, and this can create an imbalance. Do you have any comments to add?
Yeah, the imbalance. So here there are two, in my opinion, there can be two solutions. One solution is so the renewables that can be tapped in Northwest Europe probably are more towards wind or than solar. And the second point is that storage is the solution. Probably in a climate like this, if you have to rely massively on solar power, probably also some form of seasonal storage is storage of energy that can be brought from summer to winter. Basically, there are several examples that could be made. What we are doing here at Wolf, we are talking about storage across few hours. Okay, at most across from one day to the next one. then there are also other means to store energy across entire seasons.
Thank you, Giuseppe. I should also note that there was a question in the chat regarding Brexit, and I would just repeat what was mentioned in the plenary session, that the questions about Brexit in general, all the information that we have available is on the website for Northwest Europe in the frequently asked questions section, about the current programme, about the future programme. And the only thing that we can say is that the UK government will not be pursuing participation in the Northwest Programme 21-27 at this time.